Hello everyone again to my YouTube channel. So today in this session I want really to show you partial part of a project of earthquake based on data provided here in Kaggle. So as I told you before, for Kaggle is a famous platform for data science and machine learning. It's a community of data science in general. Well, I tracing today this dataset of earthquake, okay, to show you some steps to work in this kind of projects. Well, as we see with me, so this data is provided by Geological Survey of United States. So the data is content rows and columns uh, between this interval of years, 1955, 65, sorry, and 2060. Okay, we want just to discover uh, this data. So because as we know, in the steps or on the process of data analysis, based on some data, there is a story. We need to understand it and discover it. Well, so for this platform, personally, I chosen to work in this. I want really to save my notebook here in this platform of level. Okay, the cloud platform. So anyone interested to creating accounts is easy. You can just go to google.com. You can create your account with Gmail, LinkedIn, or something like that. At this time, you have the ability to see all the dataset here, okay? And also, you have the ability to share your notebook, or you have your own contribution in some problem. So here I trade in this problem, okay? So this is context here. We have uh, some variables or some features here, and we need to discover it, and they will show for you how we can do that, okay, just with a piece of information. Well, to create a notebook, we can go just here, new notebook. At this time, I'm gonna open a new notebook. So for me, I starting before my notebook. Okay, we'll just show you these tips because it's very important, and all these tips is the same in the most projects. Uh, we need just to discover and understand the features and this data set. Well, what do you do here when we create in our notebook? So this is the page. So we go here. We can rename our file here, and in the left side we have this information about data. So in my case, this is the data here. Okay, this is the input here. Earthquake database is the file of dataset. Okay, and here we have this zip file. Okay, well, to work and to see the content of these files, we can just go here, creating variable. So in my case, I call it path. So in the path, I start this link of my dataset. Okay, here you can just go here, kind of copy it here. Okay, copy directory, we paste here. Okay, and the next step or second step here is to import all the packages I need to discover my dataset or building my model. But for now, it's not my final project because I just apply some feature here to show you how we can build in steps to discover uh, this dataset, how we can clean it. Okay. Well, so for now, 3 packages is more enough to start this process of analysis. So in my case, I will work with pandas. So pandas, I and this is famous packages for analysis in Python. Okay, is more important package here. It's not more important, but it's for data frame because as we know, if we are facing some files, we need some things to transform it like a data structure. We need a structure to work with, okay? Because we cannot facing a lot of files with different format. At this time, we need some things help us like that to combine and read all these files. So here also I apply this Seaborn. Seaborn is for statistic visualization. Okay, it's for statistic visualization. We can see distribution of variables. We can see bars. We can histogram. We can see a lot of things here. Heat maps. We can see the correlation and a lot of things we can do with Seaborn. And also for Matplotlib is for basic visualization. Okay. So 3 is enough for us to start in our project. So here in this piece of code, we have PDC option display max columns and the rows. So the idea behind this piece of code is to apply when I run my data frame. I need to apply or return the maximum possible of columns and the rows because in some time you can facing thousand and thousand millions of records. Okay, in Kaggle there is a lot of projects with this huge number of records. So as a data scientist, as a data scientist and data analyst, I need to return maximum possible of all these max or columns and the rows. Okay, so let's start for now. Here in our case, the file is database of CSV. To read this file, I created a data frame called data equal to pd.read CSV. Why I apply this function? Because my file is CSV. Okay, in my YouTube channel, I discussed that before. There is a lot of format, Excel, SQL, JSON, for example. There is a lot of file or extension of files. So for this reason, we need to apply each function. That's depend of the format or extension of file we have. So in our case here we have CSV. So for the reason I apply this function of reCSV. So reCSV as function so as attribute here, this is the path. Okay, as attribute is the path of this file. Okay, or I can copy all this file and put it here just for organize my work. I just put here a variable represent the link of file. So I run this, I get this result here. Data.head, data for head is a function to return by default 5 first rows. I discussed that before. Okay, data.head just for return the last or the first 5 records. There is another function called till, so we can also use it to work with it if we want this. I remember it just now. Well, we can also create another data.till. Well, yes. So if I run it, so here I can check. Okay, we're looking here. I can check the last 5 records for hit the first 5, and for till the last 5. Okay, so as we see here. Okay. Okay, this is our data. Here, there is another functions here is a column or attribute. Sometimes you're gonna facing a huge number of columns. There is no ability to see all these things when I run my code with head or tail, whatever. For the reason I need to using this function of or this attribute sorry of columns is return for me all the columns exist in our data frame. So in our case, all the features here is clear, okay, as we see in our data frame. all the records here is clear. So we have column of date, we have time, we have latitude, longitude, we have type, we have depth error, we have depth seismic stations, we have magnitude, we have magnitude type, magnetic error, magnetic seismic station, azimuthal gap, horizontal distance, horizontal error, both mean square. We have ID, we have source, we have location source, magnitude source, and statue. Well, so this is a function or attribute of columns just to see all the name of columns exist in my data frame. Also, there is other function I remember it now. Data is to see the shape of my data frame. I mean, how much of rows and columns I have. To do that, we can just apply this shape function. Shape is if okay, if I run my data, this is how much of row. So the first part of this array is a content number of records or number of rows, sorry, and this is in the second part of this array is the number of columns. So in my case, we have 21 row and 20,000. Let's see, okay, is 23,412 row. Okay. Well, so the second step that we can do is to see how much of non-value we have here, because in the most of time we're facing this kind of scenario. I mean, when I read data from some source, there is high ability or high probability to have missing value in my data. So for this reason, we need each time to check in my data how it is. Well, to do that, so I prefer this to see the null value visually with bar. To do that, we can just so data it's our data frame, and we have is now is a print function just to return for us is a boolean text, okay, to return for us if the data content null value or not. And we apply also sum because I want sum of all the non-value in each feature or in each variable. So for me, I apply also this plot function just to visualize this with bar. So you have plot kind is attribute equal to bar. I can choose anything here, but in our case, I work with bar to see how much of non-value we have in our data frame. So as we see here with me, visualization, we have all the columns here in the X axis and the number of data in Y axis. Okay, we have non-value in depth error, we have in seismic stations, we have also in magnitude error, we have in azimuth gap, we have horizontal distance, we have horizontal error, and we have in root mean square. And the most one here, the most non-value is in the variable of magnitude error. Okay. Well, there is no reason. We don't have much information to understand. Sorry, why we have this non-value in this specific variable. But we need to clean our data. Okay, this is a lot. Very sorry, a lot of strategy to follow to replace all this non-value with something. Okay, we can drop, for example. Okay, first strategy is to drop all the data, but it's not preferable really because when we drop records or columns, we lose a lot of information in our data. Okay, but if we have, for example, more than 50% of non-value at this time, we can drop, but we try to avoid this strategy really. because that does not help us for it to extracting a lot of information. Maybe we can lose a lot of information. Okay, for the reason we avoiding this, or we can create in our notebook or our analysis based on this strategy. I mean, I can create notebooks. So when I see how much of non-value I have in our data set, I can drop it and see my analysis how it is and compare between this, or maybe we can replace it with a mean in case of we have normal distribution in our variables statistically, or median. Median we apply it when we have non-normal distribution, or the mode we use it when we have in category variables. I mean, we try to replace non-value with the most frequent value in our variable. Also, we can make in predictions based on machine learning algorithms. We have this ability also. Okay, I mean, try to predict the value that can replace this non-value, or also we can create our constant value based on domain knowledge. Okay, because when we try to solving this kind of problem, we need to have a domain knowledge, or at least be in the staff. People have this knowledge in some area. Okay, we can have some steps or some information can help us to creating a constant. Okay, so there is more than five strategy related to follow it to replace this non-value. So as we see here, this is all non-value we have here in our case. Okay. Also we have these famous functions. It's info functions. So data.info. So info give us three things. We give us the columns, all the columns we have, name of columns here. You see with me, we have data.info, all the columns we have here. And the second thing here is give us the number of the records we have in each variable. We can just see if we have a non-value just with number, we compare the number here as we see. Okay, we have some non-value or missed value, sorry, we have some missed value here. And the third things that we can see is the type of the type for each column. So if we take an example of a date here, this is object. Type also is object. You can see type float. Oh, sorry, is object. Longitude is float. You can go in ID is float. Okay, the type for each variable. Why that is important? Because if we try to do some transformation, try to make engineering phase or data cleaning at this time, at least we have an idea about each type for each column, because date is not object, it's a date. Okay, the first transformation here is for date and time. We need to transform it to make it as a date, it's not object. Okay. So for this reason, the info function is important, very important. We have other syntax calls to discover the type of each variable, but here for info, it's a famous functions can use it to see each column and each type for each column. So let's continue in our process. Well, here. So for me, really, because I don't yet complete all the project. I want just to working in some part, because if we go here, show you. So here in this type, there is two things. There is two variables. I will show you now here. Oh, sorry. Okay, you can add in a cell here. Now we go. Good. Right. I run it. So here in this type column, there is two things. We have earthquake and we have explosion. We have nuclear explosion. We have two values here, as we see. Okay, we have nuclear explosion and we have earthquake. In my part of project, I want just work in explosion. Okay, sorry, I'm just uh, I just apply this function of heat. So okay. So here in this dot type or in this type, we have two values. We have earthquake or nuclear explosion. In my part of project, I choose to work in this nuclear explosion. Okay. I want to share with you some steps. Maybe can have some or can ask some questions and try to find answer for our questions just based on this data. Uh, well, here, okay. So separate data based on type. So here I apply this filter. Okay, the filter, I want just nuclear explosion. To do that is easy also by creating another variable called data nuclear equal to data type nuclear explosion. I want to return just the data content nuclear explosion. Okay, I return or I create another uh, data frame based on this filter. Okay, well, sorry, I need just to one minute. This work. So if we see here in type, we have just nuclear explosion. Okay, I want just this data of nuclear explosion. Okay, yes, that's what. Well, if we go to the next step here is to discover null value again. I want null value in my the new data frame is or in data nuclear. Okay, so to do that here, firstly I do it with a plot of bar, but for now I apply another technique is technique of heat map. Well, this heat map is a matrix of columns with all indexes of my data. Okay, so plot figure fixed size here I give so just to make it more clear, more big. And CNS heat map data nuclear is null. I want the data null in my real life, and they show it here with a altitude show. It is syntax is easy, not complicated. Well, this is the result. Okay, this is the result here in this matrix on this map. Okay, so this width area is non-value, content non-value. Okay, we have in left error, we have in arithmetic gap, we have also in horizontal distance. Well, the idea here is to show for us how much of non-value we have in our data set. Okay, this is another technique to see the data how it is here. Okay, so show for us how much of the of non-value we have in our data frame. Well, let's go here to show the percentage or the rate of non-value in our dataset. It's easy. Estimation equal to beta nuclear dot is null dot sum divided by the length of all the feature or variable I have times 100. The idea behind this is to show or to discover the rate of non-value I have in my data frame. Because as I told you before, if we want to drop, for example, I need to specify a criteria for that. If I have, for example, more than 50% of my dataset is null, at this time I can drop. Okay, so for this we need to specify how much of or the rate or how percentage of is the data in each column or each uh, variable. So if we take in this example of this error, we have 93%, 90, around 93% of missed data. That means is most of values is missed. I don't know is that is randomly missed or there is some factors contribute to drop or remove those data. Okay, but anyway, just in steps of analysis, it's good to have an idea about our dataset, how it's how much of non-value I have in each column. Well, here I want choosing just the data or numerical data. To do that, it's easy also. So in my data frame, so data nuclear dot select the type I want to select. All the columns is integer 64 or float 64. Okay, I want the columns with this dot type. Okay, after running my data, this is the result here. Okay, this is all the columns with this type of integer or float. Okay, sometimes we can facing some we can add in also the float 32 integer 32. Okay, can add in that in our list to return all the columns with this specific type. Well, what I do for here is creating another variable called name call, and I copy all these name of columns here and I paste here. Okay, so the idea is to see or do some analysis in this name call. Okay, well, if I continue here, so my own strategy is to replace all the non-value with media. Okay, especially I chose this because as I tell you before, it's not the final project. I want also creating multiple notebooks. Some I will creating or in the same notebook I will creating a copy of my data frame, and they will test each strategy by itself, and in the end they will compare all the results. Just I will show you these steps after my working in this project. I will share with you the final version of my contribution of the notebook. Well, here in this level I choosing this median. Well, as I tell you before, one of the famous strategies that can use to replace all the non-value is the median. Why median? Because it's not sensitive to outlier, because there is an outlier in our dataset. Okay, the outlier that means some values is exist in the extreme left or right of my density function. Okay, so for this reason I choose to replace with median. Okay, we can also replace it with mean in case of normal distribution. I mean, we have this bill curve and we see our the density or our distribution of or our function distribution function. This bill curve it will be normally distributed. At this time we cannot place the mean. So we cannot place the non-value with mean. But in our case, in most of the cases before, is better to use median. So to do that, I will create or writing this. So data nuclear dict error, the same name of variable. I want just change the same variable. I want replace non-value with the median. So the data nuclear dict error equal to data nuclear dict error dot fill now. We have this function. I discussed that before in my playlist in Python. Anyone interested to know more about this and how or what is the attribute of this function of now, I can check or you can check sorry my playlist in my YouTube channel. Okay, playlist of Python. I discussed that before. Well, fail now. Okay, data nuclear. I want this. I chosen this specific column dot median because fail now give us the ability if the process or the algorithm behind this function is to check each value for each value for this column of the error and replace it with median of this error, or the median of this depth error. Okay, each median or each column for each column, sorry, with own median. It's not the median of all the seed, but the specific one. So the same thing with depth seismic stations. Okay, I replace it with median, also specific depth seismic station. For magnetic error, the same syntax. I do it with this method just to show you how we can use the fill. We can also create in our own function and apply it each time, but I tracing this just to show you how we can work with the syntax of fill. Okay, for horizontal distance, for horizontal error, and the root square. So after running this, okay, we'll run it again. Yeah, okay, it's okay. So I run here. Now if I go, it's okay. If I apply again the heat map here, because I apply heat map before here. So here we have non-value with this with area, all non-value. After replacing the non-value with median, this is the final result. There is no non-value here. Okay, this color mean there is, okay, if we are checking this bar here, okay, this color is existing here. That means there is no non-value here. All the area is with the same background color. Okay, that means there is no non-value. So if we go here, here I want to show you, okay, sorry, I want to see the distribution plot of our numerical column. So for the reason, as I told you before, we choose here just the integer and float columns. Let me show you here, okay? I trade in this just to see the distribution for each column, here. Sorry. To do that, we can just create in this num of rows equal to length of num column plus 3. I want to create the C plots, and I want to create my C plots. So for the reason I'm writing this, it's for just number of columns as needed. We have number of columns I want here is 4, and to create this function for this loop for each and var in enumerate number of column. Okay, I want to see plot the number of rows and number of columns. Okay, and they want also distribution plot for each column of my data frame. Okay, here we have plot type y just to make some space between all the plot we have, and also we have plot copy altitude to show my visualization. Well, this is the result that I did here. Okay, so we have here, as we see, we have some outliers here. We have 2 mode. So in this latitude is not below the normal distribution, as I told you before. So we have some 2 mode here, is not normally distributed. Same thing for longitude. We have also for depth, okay, is not normally distributed. Okay. So here for depth error, same values, okay, consider it like unique value here. So the same things for magnitude, and each of our column here you can see distribution how it is. Okay. So okay. So we can check and analysis analysis or visualization, how it is. At least kind of building our view about the variables, how it is. Okay. So if I run this piece of code just for keep plot, so just by taking each of these visualization, I make it more clear. As so for the error, we have the same value. So for this, we have this horizontal vertical line here. Okay, because we have the same values. Because if try to count here the number of data, okay, as I see here, data nuclear, we have typed error dot value count. I mean, I count the number of each value we have. Here we have the error is 31.61 is 175 times. Okay, same value is repeated in the same on all data frame we have here. Okay, let's go. Here, why I apply this nuclear or data nuclear.info. As I told you before, here we are check the columns, okay, and the type and the number of the rows we have for each variable. Well, here checking the values category variable. Well, I go here for my object. Okay, I go to my object variables. So if we take in magnetic type, here is object. Object, I mean, I don't know specifically what is the kind. If it will be integer, I need to transform it to integer, or I need to make it as a str, I mean string, or date. Okay, that's different. But the most important here is to discover uh, the values we have in this variable. And to do that, we can just choosing the columns that we want. So in our case, we have data nuclear magnetic time dot unique. This function of unique, it show for us how much of value we have here. Unique, I mean, not duplicate values. So in our case, as we see in this array, we have two values. We have ML and MB. Okay, we have just two values. So the same thing for source with object, as we see here in info. We have source.unique, we have C and US. Okay, so the same thing for location source. We have also two values, and we have magnitude source.unique. We have also two values. Okay, why I do that? Because when we try to apply some algorithms, the algorithms does not understand the object or string or something like that. We need to make some transformation. For this reason, I need just to check how much of value we have in each variable object here, especially because when apply this function of info, it just trace the object type. And with using this function of unique, I want to check how much of value we have in each object or this uh, object that type. Okay, we have this. We have type is object. Okay, we have the values here. For also status, we have one. We have review. Well, the next step here is to replace those things with numbers. Okay, we need to replace those values of CA or US with reviewed with some numbers, some meaningful numbers, because when I try to give for my algorithms those features should be numbers. So for this, what I do, I use this function of replace data nuclear and magnetic type. First one, dot replace. I apply this function of replace. What inside of this function of replace, I create in my dictionary. I discussed that before with a structure in Python. List dictionary seed. Anyone interested to know more about this data structure in Python, can you check in my playlist in my YouTube channel? Well, here we have the key in L. I want to replace it with 0. And we have in B. I want to replace it with 1. And in place 2, I mean, I want to do that in my data frame. Okay. For this reason, I give as a value for my attribute here replace attribute value to change that in my data frame. Okay, I hope that's clear for you all. Well, so the same things for source. Okay, the same value we have just two values here. We have C. We have I want to replace it with 0. US I want to replace it with 1. Okay, we have other technical one hot encoder. Okay, one hot encoder. I want to discuss that later when I will work in all dataset. So also the same things for location source. I replace it with these two values 0 and 1, C and US, and magnetic source, and also for statue. Replace it with 0 because we have just one value, the key. We give the key, and I want to replace it with 0. After that, after a running of all these things, what I did, okay, just run that again. Yes. Okay. To run again. To run again my cells. Just to operate them in here. Okay. And as I tell you before, so let me create another cell here to show you. Well, we have data. No, have data. Declare. Why I do that? I want to just show you. We have another columns. We need to transform it. So if we take in this example of date here is the object. It's not recognized. Okay. If I want to visualize that or do something like that, it's not meaningful. Okay, object is not object in Python doesn't mean anything. Okay, it's not specific that time. So for this reason, I need to transform that. To do that, I want just to use into the type here. Okay, just show you here. We have so is a feature engineering, of course. Okay, this phase is a part of feature engineering. I mean, I need to transform, make some changes in my features. So to do that, data nuclear date is another. I create another variable inside of my data frame is equal to pd dot time. I mean, I want to transform this dot date to that time. Okay, I want to. So this is the first step. I want firstly transform it to that time because it's an object. Okay, I need to transform it to at that time. At this time, I need to separate these things. Why this phase is called feature engineering? Because I try to extract to creating another feature not exist in my original data set or my original data frame. I created another one here called year. So in my year, I want to extract the year from this date. After transform it to that time, I need to extract a single number as year. To do that is a data nuclear date, not that the date as alias of the time here because I apply this package of that type. Dot str first time as a year. I want year here. Okay. I want also the month. Okay. Same syntax. Month for the data nuclear. Okay. Date dot name dot str 15 as a month. We have also day. Data nuclear day equal to data nuclear day dot dt dot str 15 as a date. After running this, I can check my data frame and see the new. Okay, I can see the new data frame I have. Okay, just let me add in a new cell here. Have data declare. Okay, I run. Wait, data declare dot hit. So after running my cell, see the result. It's taking a few time because I'm working in my cloud, so connection is not stable. Okay, finally get the result. So if I go to the right of my data frame, this is the new data is added here. Okay, we have year, we have month, and we have date. And if we remember all, there is no these columns before in my original data frame. I add it now. Okay, well, after creating the new feature or the new variable here based on this data, I need to drop this one. Okay, sorry. Okay, because if we check in here, we have 1966. So if we go here, this is 1966. Okay, well, I need to drop this one. I don't need it again. Okay, date here. I not to drop it in my data frame. So to do that, I can just to creating this. We have data equilibrium of drop. Yeah, we have this function of drop columns. So inside of this drop function, we have some attribute like columns here. Gonna assign the name of a column that we want to drop or remove. In place two, that means I want to drop it in my data frame. So after running, okay, after running, there is no date again. So the same things with uh, same things with hour. Sorry, with date. Okay, same things with date. So sorry. So here for this time, okay, if I go here to my data frame, I will show you. So we have time here. I want to extract the hour and minute and seconds. After that, I can drop the time columns. So as I told you before, we so based on this time, we can creating another variables based on this time. Okay, and to do that, we can just create data and where hour equal to pd to that time. I need firstly transform this time to at that time. I want this format of hour, minute, and second. And I will choose hour. First one, dt to hour. This is the alias for that time package. Okay. So the same thing is for minutes. We have minute here. We have data frame equal time format. Hour, minute, second, and I want minutes, and I want finally seconds. Okay. So let me run this cell. So after creating the new data, I want also, sorry, but I want also creating, but before that, okay, let me. So I want to drop this time because I don't want it. I'm creating my hour, my minutes, and my seconds. And I drop it. So let's check in again my data color. See, data on. If I check, we have hour, we have minute, and we have second. Okay, I separate these values with adding the new feature. That's good for our analysis. And so after that, I will check in this time. What's happened here? I created a bar plot based on what? Based on year and the depth. Okay, I tracing year as a x-axis and y-axis is depth. Depth of my earthquake. Okay. Well, if we go here, we are seeing all the years we have in for nuclear data. Okay, and the most depth, okay, the most depth is in the year of 1983. Okay, the most depth is happened here because in this phase we're working with nuclear explosion. Maybe we have some experiences at this level, and we see the most depth is happened in this year. Okay, the most depth is happened in this year. Okay, and also I chose a year with magnitude. The measure, the magnitude, so the magnitude in earthquake, we can see it with a Richter scale. There is a mathematical formula to calculating the magnitude. I discussed that before with Mercalli scale, but we have Richter scale is most useful scale. Magnitude, there is a formula for that. Okay, well, here I trade in x-axis here, and for y-axis I trade in magnitude. And see magnitude here since 6060 to 96. Okay, this is maybe we have seen magnitude in all these years because we are in nuclear explosion, the experiences of this bomb, nuclear bombs. Okay, maybe because this is not I don't create that in my imagination. This just I try to discover what's happening or what is the data content. Okay, we have here data nuclear. So for this reason, we have the same magnitude maybe. Okay, can ask kind of creating application based on that. Okay. Well, also I create another visualization bar with x-axis as year and magnitude seismic stations. We see the most magnitude seismic station is in these last years. I mean, from 1992 to 1996. Okay, why this is high? Maybe because we creating the new magnetic seismic stations. Okay, we creating another stations to measure or detect this earthquake. So for this reason, this is my personal interpretation. Maybe it cannot be wrong, but just I try to give some meaningful for this data. Well, I create another one ticked error. I have seen ticked error in for all the years. So based on these, so we have years and we have ticked error for all these years here. Also, I create another visualization based on math. Okay. So as you see here, so we have figure big size here, TP, 20, fixed color, width, and edge color is a width. So this and that is simple. For bar plot, I treat in here month and depth for x or y axis. Sorry. Okay, and we have the most depth. It's happened in month 10. Okay, maybe the October. Yes, there is another month here. Okay, but the most one is happening here. So maybe if we check for this here. I can check for all the month 10 for each year we have in the dataset. We need to find some reasons for that. So this is the rule of analysis. Okay, just try to find some explanation for our events based on what we see here in our visualizations. Well, So the same things here. I give or I trade in demand with magnetic expectations. Okay. Well, so we go. Let's see. And the earthquake detected by these stations. So in different ones here, of course. Okay. And also creating by hour and magnitude. Okay. I mean, I want here just to see which hour have high magnitude. Okay. After I seen that, it's happened in 8 p.m. 8 p.m. Okay. 8 p.m. Okay. Most week happened with this explosion nuclear, like nuclear explosion is happened that is my explanation based on this data provided. It's not my for it's not my personal effort. Okay, so we try to interpret based on the data provided. Well, for you, then we have our um, yeah, just it's the scatter plot. Yeah, I don't work it yet in this. So scatter plot, the rule of the scatter plot, we try to discover, see the relationship exists between two variables. So in my case, I trade in the year and magnitude. Okay, and this is this point in our plane here. Maybe it's a weak, maybe it's a medium relationship. It's not weak, but it's a medium relationship. So we do this pattern of all these points we have here in our plane. Okay, um, so that is just scatter plot data. So for negativity data, I find data nuclear and X is here. We have analytic easy syntax. Well, there is another thing important is a correlation. Okay, to do that, we can just data nuclear numerical column because I filter that field on the integer and float because the correlation does not work when we have categorical data. Okay, for the reason I do it just for numerical column. Okay, this is all the data we have. So latitude with latitude is equal to 1, meaning a strong relationship. Have longitude and latitude is a strong also relationship. Okay, have quick relationship here with that distribution with our latitude. Well, the goal of correlation is to discover uh, relation between two variables, and we can do that with a heat map. That is more clear. To do that, so we have the syntax. So it enables heat map, data necro number column, like join just in variable dot correlation are not true. Okay. Well, this is the relation or the measure of how it is the relationship for each variable that we have here. Okay. So there is another level or advanced level of analysis that we can apply another technique like PCA, principal component analysis, because this analysis is not enough really, because when we have in the phase of prediction or building the models or algorithms to predict, at this time we need to reduce uh, the dimension of our model. And to do that, we have PCA, for example, as I tell you before, principal component analysis. We have also LDA, we have the TSNA technique. Okay, we have a lot of techniques that we can follow to make our analysis more clear and more interpretable. Okay, that is the basic. That's what we share with you. Okay, I don't find it. Don't I don't yet end my project. Okay, this is some basic steps what I share with you. When I ended my project at this time, I can share with you all the steps, and they were writing that directly in our section. Okay, let's hit map to show for us the relationship we have for each variable. So let's go more deep. This phase of view spatial analysis phase, because in our dataset we have two interested variables, is a latitude and longitude. Both of variables interested to visualize the area. Okay, well, this is a part of view analysis spaces or view spatial analysis. So we have a volume package for maps, and we have view pandas to make the data ready to see it in our map. So here what I do, I'm writing or I transform my latitude and longitude as a geometry. Okay. We have if creating another variable count if equal to data nuclear.log. I want all the data of latitude and longitude. That's why I use these log functions. I discussed that before in my playlist of Python. We have also this df info just to check the data we have here. Okay, after running that, I want the information for latitude and longitude, and creating points for geometric point. Well, geometry equal to pandas point from x and y. I want to extract x and y from this longitude and latitude. I want to separate them. Okay. After that, I want to transform it like a U data frame. We have data frame and we have U data frame. To do that, we have U df equal to U panda to U data frame. Df for latitude and longitude geometry is geometry because this is. And after running, I get these results. I try to create a new table of data frame, calculate just latitude, longitude, and geometry. I combine two points here. I want to combine two points here to make it easy in my visualization. Well, after that, what I do, I want to see that visually. Okay. Well, I applied volume. I import plugins from volume. Map volume with map location. I want this location because I chose that randomly. The first record of my locations I put it here in this list. As tells, I want dark one for the nature in this card the black matter. So the zoom of this is where we start from 2. We have hit data point of x starting from 1 0 and point of xy 0 0 from point my geometry. Okay, and hit data. I want to visualize hit data, and I want to add my plugins in my heat map here. Okay, I want to add this plugin, and after that, this is the result here. Okay, this is the map. This points here is represent this location. Okay, I can change and take it any location I want in my longitude and latitude. Okay, and sorry, here if I zoom, so I can zoom and go to see these 2 points we have here. So all the country of the world here. We have this hot one here. This is maybe the place for training or for exploring based on this data. Okay, based on this location provided in this dataset. Okay, can check this point here and go more and more and try to see coral. Some place here, I don't know. Some people maybe okay. See some places to this try to test this earthquake or see the earthquake we have here based on this type or the filter that I created before. So is another one here, creating another based on some other location compared to this one. Okay, this is location is different here. I created another one here, another future location. Well, if after running, this is the result that I did here. There's another place from Asia, okay, area here, and all these places is for uh, data nuclear explosion, something like that, based on the data provided for uh, just this map show for us where is the place to do this earthquake. Okay, so I hope that's clear for you. I want here is a part of our project. Okay, after so I hope that's clear for you all. Okay, and after uh, my final version, I will share it with you. Just I share with you some steps, some basic steps to create a new notebook. Happy learning for everyone. See you again. Bye bye.